equals then magnitude A squared plus magnitude B squared minus magnitude C squared. So far so good? For the logic here, we're just solving. Now, Joe, I heard what you were saying. So the left-hand side is equal to what? What does the left-hand side turn into? 2A dot B. Now, we're getting close to what we actually want to have happen. Okay, what I'm trying to do is I'm trying to get A dot B in terms of Cartesian vectors. That's what I'm trying to do. If you've taken a look at what I've actually done, is I've got A dot B, there's no theta in here at all, right? So A dot B right now I have in terms of Cartesian vectors. You want to get this looking a little bit nicer, because right now that's a little bit sloppy. If I want to solve for A dot B, what's the next thing I should do probably? I'm letting you guys take me through this, I'm not doing it. If I want to solve for A dot B, what's the next thing I should do? Sit there and hope the class ends. No, that's not true. Go ahead, I heard you say it. Divide by 2 sounds good to me. So I'm going to say A dot B equals magnitude of A squared plus magnitude of B squared minus magnitude of C squared divided by 2.
Why couldn't we just use 2 magnitude of A magnitude of B cos theta?
Because the idea is we're getting rid of theta, right? Because the idea is in Cartesian, there's no angles. Okay, so what I'm trying to do is to have everything in terms of Cartesian vectors. Like if I have a vector, basically I'm going to want to do this in a few minutes. Okay, that's what I'm going to want to do. And I'm going to want it to turn to something nice and not having to draw it out and measure with my protractor and all that. I don't want to have to do that. Okay, can I get someone to be brave now and to tell me what magnitude of A squared is going to equal? How do you find out what magnitude of A squared is going to be? Ben, go. Oh. No, I'm going to stay away from that. Okay, that is true. That is true, but the problem is it's not going to really help us. I'll tell you what I'm going to try to hope here. I have A and B and C, but I'm going to try and just turn that in terms of A and B. Okay, because if you take a look, C I already have in terms of A and B, so that's going to work. So how do you get the magnitude of A? What's the magnitude of A going to be again? Oh, come on, guys. How do you get the magnitude of a Cartesian vector? Yeah, so this is going to be the square root, hopefully, of AX squared plus AY squared squared. That's what the magnitude of A is. Is anybody following me here? Other than Michael. Michael's following me. One person? Okay, well just think about this, our definition of the distance of a point, right? The distance of a Cartesian point, right, is going to be the square root of the x value plus the square root, right, the distance, so we see the distance from it's all I'm using here. Okay. In the same way, I'm going to maybe go to a new page here. I do the same thing for y and z here, or for B and C. Okay, so for B it's going to be the same thing, which is the square root of bx squared plus by squared. Now C is a little bit more interesting. Okay, this turns into AX. Which was that? Oh, thank you. This was AX minus BX squared plus AY minus BY squared. And that's all squared. Okay, can somebody please tell me why? Oh, that's all over 2, by the way, too. So the squares do all cancel out, which makes my life a little bit easier if I have to write smaller. The squares and the square roots all cancel out. So this is just equal to AX squared plus AY squared plus BX squared plus BY squared. Now, how am I going to deal with these two on the right-hand side? AX plus BX all squared. AX minus BX squared. How do we deal with that? Yeah, expansion of the FOIL. So this is going to be minus bracket AX squared minus 2 AX BX plus bx squared. And then finally, this is going to turn into plus ay.
Minus with K.
Well, I left the bracket here, so we don't have to. So plus ay squared minus 2ay by. Oh, I'm not going to make it plus by squared all over 2. Now, I know you're saying, oh no, is this ever going to end? The answer is yes. Hopefully. Okay, so let's try and get rid of this and see if this is going to work out nicely here. What's going to cancel here? The answer is going to be a lot. Ax is going to cancel. Ax squared cancels with negative ax squared. Plus ay squared cancels with, that's a minus, so that cancels out there. Plus bx squared cancels plus bx. Plus by squared cancels plus by squared. So what this turns into, and I'll go up top so everyone can see, this turns into then a dot b is equal to, it looks like I have 2ax bx plus 2ay by over 2, which hopefully turns then ax bx plus ay by, which is very, very cool. Okay, what that actually means is, in order to get a dot b, all you're going to do is you're going to multiply the x components together, and you're going to add them to the y components multiplied together. You may have to reproduce that one day on a test, because I'm evil. Before you say it, I'm evil. I will let you know what you have to reproduce. You may have to reproduce this, so if I say reproduce proof of dot product or cross product or something, that may be one, because I am in a bad mood today. Okay, let's go through the application of this. Once you see this in action, no one looks impressed right now. Shalina looks like she's going to be a little sick right now, okay, after seeing that. But once you see this in action, you're going to say, wow, that was nice. Okay, you don't believe me. This is nice, though. Here we go. Mr. Kemp, I just proved dot product, and everyone looks a little gross. Yes. Okay, so this is where life is nice. I have u and v in terms of, I'm going to do this one example, Mr. Kemp, then I'm going to stop, okay? So, and actually then after this, you're going to get your real homework. So it says, if u is 2, 3 and v is 3, 4, find u dot v. Let me show you the magic power of the dot product in Cartesian form, because this is nice. All that we just proved is that in order to get it, you're going to multiply together the x coordinates, then you're going to add that to when you're multiplying the y coordinates. So what this means, it's just going to equal 2 times 3 plus negative 3 times 4. Okay, so what I did was I multiplied the x coordinates together, right? 2 times 3. I added that to the y coordinates multiplied together. So this equals 6 minus 12. That equals negative 6.
If anybody in here is taking data management, that's basically the product of two matrices. If you remember your matrix multiplication from data, it's the same kind of thing. So, yeah, remember that now? Yeah.
Okay. That's why that's nice. Remember all that hard work that paid off then. Okay. Here's ready for 1,000 questions for homework. Here's 1,000 questions for homework. Homework's going to be page 376, number 10, 11, 14, 17, 18. If you're saying to yourself, oh no, I have 4 hours of badminton to play tonight, and you're unable to do all your homework, and this happens to people, I understand. Someone in my 11U class is trying to make a deal with me saying, hey, maybe 4 nights a week we should do homework and get 1 freebie a week. I said no. But if you have though a night where you're saying, oh man, I worked really late, I couldn't do all my homework, what might be a good question to start at? It might be good to start at 18 and work your way back, saying, Mr. I didn't have time to do 1, 2, and 3, but you know what, I tried 14, 17, 18, I got them, then I'll be a little bit more sympathetic, okay, for that, okay? But if you say to yourself, you know what, I didn't do any of it because I was up until 2 in the morning playing, watching Doctor Who, okay, or whatever it happens to be, there's that. Okay, Mr. Kemp, sorry to interrupt. Go ahead, I'm going to stop this.